Well, thank you all for coming, and I'm excited to tell you about our new, ideally simple package that we call axolotr. We, like many people, have been enraptured by these LLMs and what they can do, what they can't do, and everything in between. And so I want to tell you today about a simple package that we built with an eye towards understanding how we can use LLMs in some of our standard workflows, hence being part of this workflow session. So we know that LLMs are everywhere. The AI revolution in coding enables us to do a lot of really amazing things. We can help with data analysis, debugging, documentation. How many people have spent more hours than they would like to admit writing documentation? Yes, or how many people would admit to not spending those hours writing documentation? Oh, a lot more, okay. And refactoring, test writing, and so on. So I don't think I need to give too much of an introduction to LLMs. But I think that this is an interesting question and what I really want to focus on today, which is how do we integrate them into some of our standard R workflows? So this requires an understanding of what the term that I will use, agents versus an agentic workflow. And Hadley, in his keynote last night, talked about his definition of an agent, which was an LLM with the ability to read and write. And I think that we would add a few more nuances to that definition. So an agent essentially has the ability to plan, it has the ability to act, and then it has the ability to observe. So here's what I mean by that. So initially, the very first step when you call an LLM is when an LLM then is programmed to analyze a task and plan some series of steps. This is the first step in the first sort of requirement of an agent. Then the second is to act. So now it has its steps that it's going to work through, and it then is going to iterate across those steps. And then finally, the very last is to observe. It needs to evaluate the results and then importantly adapt to the output of those results. So if we have an agent that is going to write some code, it will determine what kind of code it needs to write. It will then write that code. It then needs to observe whether or not the output of that was successful. So there needs to be some metric to determine if this was completed or not. And we call that observe. And so evaluate the results and adapt. And so what will happen then is at the end of observe, the concept is it will come back to the plan. And it will then determine if I completed that step. So let's say I had a 3-step plan. It will move through step 1. And in this observe part, it will determine whether or not step 1 has been completed. If it has been completed, then it will move on to step 2. If it has not been completed, it will come back, determine what needs to be done to complete step 1. And so this is essentially one of the early definitions of an agent. So an agent has 3 steps. And how do we do this in a programming language like R? Well, we are going to then have an LLM that will determine some of these steps. And we do this essentially in a loop, right? So this idea, this plan, act, observe, this is not magic. It's not that hidden. It is essentially functions operating in a loop. Okay, so agents are considered autonomous because in this very first step, you will say, please make me a plan for exploratory data analysis. Right? And this is sort of open-ended. You're not saying first, I would like to import my data. Second, I would like to then clean my data. And third, I would like to visualize the raw data through some histogram or something. No, instead what you're saying is please analyze my data. And the LLM then is making an autonomous decision about the user's intent. So if you then prompt the LLM to say, please analyze my data by first, or please perform exploratory data analysis by first, second, third, fourth, and so on, then the plan is going to be much more hard-coded into your instructions. If you don't do that, then the LLM is going to infer your desire or your request based on your prompt. So your prompt could be a page long or it could be a sentence long. It doesn't really matter. The agent or this planning step is going to come up with a series of steps or a series of functions that it will perform. Now, it turns out that when we think of agents, we can think of a chatbot. You have a chat, you're going to send a question to or a request to a chat, and it will return something. All right, so this sort of in and out is an important feature, and I'm going to talk about the function or the package that we wrote that simplifies this functional-based approach. So agents, though, if you say, please perform exploratory data analysis, and the agent then is going to come up with a series of, let's say, 17 steps. Okay, that might be way more than you ever envisioned. Okay, so this autonomous aspect can be beneficial, but it can also be a problem, right? Because maybe you don't want 17 steps. Maybe you just wanted your histogram of your raw data. Okay, so when we think of some of this different terminology, we can then think of our traditional workflows, and we can think of a full agent. And what I would argue is that there's something intermediate here. Okay, and there's something that would be considered an agentic workflow. So this agentic workflow is perhaps nuanced and perhaps completely made up just for the purpose of this presentation. But the idea here is that we have a workflow that we're going to be stepping through. And one of the trends that's emerging in this AI-empowered LLM-based space is that the tasks that you hand off to the LLM are going to be very intentional. You might not want to hand off all 17 steps of your exploratory data analysis to the LLM. What you might want to do, and this is again calling back or thinking back to Hadley's example that he gave in the keynote last night of extract the name and the age of this 5-person data set or 5,000-person data set, it doesn't matter. But you might do that, return that output, and that would be your LLM-based step. But you might then just include that in some other exploratory data analysis workflow that you have. And so if you have a full agent, you might say perform the exploratory data analysis and everything happens. Or there's this intermediate step where we can start thinking about which tasks that are part of my workflow would be enhanced or augmented by an LLM. Because I might not want all of my tasks handed off. Okay? And that's where this agentic workflows come in. So it's sort of this practical balance of automation and control. I think that when we think about data analysis tasks, we can identify the ones, again, like this, I think, excellent example of the name and age problem, of extract this information and then take that information and do all of the things that we would normally do, like take these ages and plot a distribution of the ages across my data set and so on. We are not going to have an LLM write code every single time we need to do that. We might just take the code that's output and drop it into our normal workflow. Also, when we start thinking about agentic workflows and we have very intentional LLM-based steps, these I think are easier to implement and also to debug. And so if we have this LLM that's doing all 17 steps and it fails somewhere along the way, then it's going to take much longer to really understand what's going on under the hood and also to then debug and figure out where the problems lie. And so I think that these agentic workflows are a really nice balance between the two. Okay, so now, if we think about this challenge of LLMs, we have multiple APIs. These are foundation model providers on the left. These also have different authentication requirements, different request formats, response structures, error handling, and so on. And so what we decided to do a few years ago was build a very simple unified approach. And this unified approach is a package that we call axolotr. So axolotr has a very simple interface. This is a functional-based approach to calling LLMs. So everyone here in the room is familiar with this concept of a function. We put an argument into the function. We get something back out of the function. This is exactly what's happening here. So we have a single unified call. We say this is ask, and we ask our prompt. We can then call our model, and we're going to get then the response from the LLM in a string. So it's quite simple. Prompt goes in, response comes out. What we can also do then is we can take advantage of this model flexibility. So here's our simple interface, but our model flexibility means that we can call these different models all within the same interface. Okay, so I developed a use case just for this, back to this concept of exploratory data analysis. So every analysis starts in the same way. We import our data, maybe we glimpse, we summarize it, plot distributions, check correlations, and so on. So what I wanted to do is I wanted to ask, what if an LLM could do some of these steps for us? So I'll show you the code in just a second, but this is generally the overview, is we take our data set, and this again harkens back to what I just showed you of this concept of these agents functioning in a loop. So we have our a function of automated exploratory data analysis. This function is going to generate a plan. This plan will have multiple steps. From here then, we're going to, for each of these tasks, we're going to generate code. We'll review the code. We'll check and see if that code looks okay. If it does, if it looks okay, we'll execute it. If it doesn't look okay, we'll regenerate it. Okay, then we can execute. If the code was successful, we can then come back to the next task. If it's not successful, we take that error feedback and feed it back in. Okay, so again, this is sort of just a general idea, is we generate our analysis code, we review the code, we check and see if it was successful, and we evaluate it if it's successful. Okay, so if we come here, okay, now this is all on GitHub. I'll show you both axolotr, the packages on GitHub, and also this presentation and this code. So I'll show you a couple of things here. So we have our library. This is axolotr. Okay. Oh, okay. Just switched over actually after Jenny. I saw her come in. So after I have not yet deleted like Hadley did. I've not yet deleted RStudio, but we're all in on positron. So all right. So we've got our library axolotr. Okay, we're going to source the script. I'll show you the script in just a second. Okay, it's going to tell us what we're doing. And then we're going to do some automated exploratory data analysis on the iris data set. Okay, so this is working. Okay, so what we're going to do is we're going to come up with our plan. The plan is here. It's our generate analysis plan. And this has 5 different steps. And so we're doing task 1 right now. Okay, let's see. Does this? The shortcuts are the same. Okay, so we can come here. And so we can look at task 1, the output. So we generated the code. We reviewed the code. The code looked good. So we ran it. It was successful. And then I wrote a couple of essentially side effects into these functions. We're saving the output, a text output, and also the PNG output. We now go for task 2, create a box plot or violin plot for each. And again, review and output. Task 3, produce a correlation matrix and scatter plot. Task 4, if I'm lucky, one of these will fail. If I'm unlucky, it will all be successful. Because what happens when it fails is it will then take that error message, feed it back into the code, back into the LLM with the code, and essentially automate the prompt that says, here's my code, here's my error message, please rewrite the code, and we'll rewrite it and run it again. Okay, so a couple of warnings, that's fine, success. All right, so we ended up then, so step 4 was successful, and now we're on to step 5, which is a density plot for each of these. So this is the idea where we can essentially take some of these pieces and bring them together into an exploratory data analysis. All right, so now if we look at the, all right, so is this, okay. So if we look at the, oh, I need to bring this smaller now. If we look at the script, okay, I'll show you a couple of things that are happening here. And now with the help of an LLM, I've commented this script heavily, right? To let you all know what I'm thinking if you want to go and take a look at this. So we can do a couple of things. We can get our installed packages that help the LLM know what packages we have so it can take advantage of those. I also gave it permission to use or to install packages if they're not there. And so if you don't have a package, then go ahead and install it. In fact, in a couple of times that I ran this demo, it installed packages. It failed because it didn't find a package. So it wrote the code that says install this. Okay, so now this is our safe eval with our capture. So what ends up happening is we essentially are going to take our code file. We can write that file, output, plot, and so on. And the important thing is there's a lot of try catches. And these try catch is going to allow us to capture the error, sort of do this in a safe way, but importantly, take the error that comes with it and pass that back to the LLM. All right. So if we come down here, clean code, this cleans up the LLM responses, extracts just what we want. This was really just a demo, some example code for this demo where we can come up with our task, like task number 1, period, task number 2, period. And so this is basically just extracting the tasks out of this. Generator EDA plan. So you can see that these prompts are not really sophisticated. Based on this data set summary, create a plan for exploratory data analysis. List 3 to 5 specific analysis tasks. Be concise and specific. And again, this is where we can leverage axolotr, where we can just ask, prompt, and we feed a model. And again, mostly for this example, these foundation models by the different providers have different strengths. And so what we can do is we could take advantage of this. So in this case, the model for writing the code is going to be Anthropic's model called Claude. And the model for reviewing the code is going to be OpenAI's model, GPT. Okay, and this was written before 2 days ago, and so this is GPT-4. But what we can do is we can then very simply switch in between these models and take advantage of their strengths. And then here we generate our analysis code, And again, just kind of going through this, you can see here's the prompt. It basically says use the tidyverse, include the necessary library calls, some of these just to make sure that it works. And if there's an error, then here's the prompt that gets appended to it. The previous attempt failed with this error, and I capture the error message. Please fix the code to avoid this error if it's missing a package, et cetera, et cetera. And again, we just take this and we feed it to axolotl. We come up with a response, and then we can return the response. All right, so it's pretty straightforward, sorts of a single argument goes in and a single output comes out. So we can do this on Iris, we can do this on empty cars, we can do this on a lot of different data sets. Now, these of course are toy data sets that we all know and perhaps love. And intentionally I'm using these because this is a proof of concept. Because what I want to do today here for you is not show you, oh my God, you can do exploratory data analysis in an automated way on your data sets. No, instead, the hope here is to show you like what's possible and to get you thinking about the things that you might be able to do. Okay, so I mentioned this, but I can use Claude to write the task, and I can use GPT-4 to review the code. Now, we've all heard about Elmer, right? And so there's a couple of differences that I think are important to point out here. So we wrote axolotl a few years ago. This is a functional design. It's a simple function that essentially tries to harmonize this mess of API calls that are required for these different foundation model providers. We have a simple interface, it's called ask. Importantly, this is stateless, right? So the object-oriented approach is going to be really important and key for chat-based interfaces. What we wanted to do is we just wanted a simple send something to an LLM and get a response. And so I think that axolotl is simple, it's minimal, it's sort of perhaps a one-trick pony, not nearly as developed as some of these others, but I think that it has a case in some interesting and important use cases. So what I hope that you took away is that these agentic workflows can make LLMs practical for everyday tasks. Axolotl is one approach, but I think it's a dead simple multi-provider access approach. Importantly, it's sort of the same model as several of these, which is bring your own keys. And so you take your key that you obtain from your foundation model provider, you put it into your environment, and then this accesses it here. I think the error handling is important. So LLMs make mistakes. So being able to take that mistake and feed it back in, whether it's sort of in the context of a script or whether you're troubleshooting, I think is going to be important. And also this multi-model approach leverages each of these model strengths. And so the last thing I'll say is start simple, because even basic automation can save time. And so if you want to get started, you can install this package, the axolotl package, from GitHub using that address. There's documentation and a README there. This talk and all of the code and everything is at my personal GitHub, so you can grab it there. And so you can go ahead and try some of this automated report generation, code documentation, data validation workflows, and beyond. And so the last thing then that I'll leave you with is we call this axolotl because here in the South, we certainly axolotl questions. And so with that, I thank you for your attention. I'd be happy to answer any of your questions now.